In this lesson, we're going to study the cross product, which is another way of multiplying two vectors. In the cross product, when we do A cross B, the result of what we get is a vector. Remember, in the dot product, if we do A dot B, the result is a scalar or a real number. The cross product is a way to multiply two vectors and get out a vector. So if A is A1, A2, A3, B is B1, B2, B3, the cross product, or A cross B, is given by the formula A2, B3 minus A3, B2, A3, B1 minus A1, B3, A1, B2 minus A2, B1. So I know this is a fairly complicated looking formula. I'm going to give you a way to remember this if you don't want to have to memorize out this big formula. So the way to do this without having to memorize that complicated looking thing is to use determinants. So the determinant of a 2 by 2 matrix, ABCD, is just AD minus BC. And then if you want to find the determinant of a 3 by 3 matrix, what you do is you go across the top row of your matrix, so you label it plus, minus, plus, and so then you do A1 times the determinant of what you would get if you crossed out A1's row and A1's column. So it would be A1 times the determinant of what's left over, so B2, C3 minus B3, C2. And then the next one is minus, so now you're going to do minus A2 times the determinant of the matrix that's left if you cross out A2's row and column. So that would be B1, C3 minus B3, C1. And then you go on to plus A3, so now it's going to be plus A3, determinant of what you would get if you crossed out A3's row and column. So that would be this matrix here, so B1, C2 minus B2, C1. So this is how you find the determinant of a 3 by 3 matrix. And now to do the cross product, you're going to put I, J, K in your top row, vector A in your second row, vector B in your third row, and then we're just going to do this determinant. So remember, it's plus, minus, plus. So you're going to get I times the determinant of what you would get if you cross out I's row and I's column. So that would be A2, B3 minus A3, B2. And then you're going to get minus J times determinant if you cross out J's row and J's column. So that's A1, B3 minus A3, B1. And then it's plus K, cross out K's row and column, and you get A1, B2 minus A2, B1. So in component form, this is A2, B3 minus A3, B2. And now for the J, the minus is going to go through, so you're getting A3, B1, minus is plus, minus A1, B3, and then in the K, you're getting A1, B2 minus A2, B1. So here's what we have in component form, and now notice that this is exactly the same thing as the formula that I gave on the first slide. So again, you can memorize out the formula, or you can think of it as determinants. I think it's easier to do it as a determinant this way, but it's fine to memorize out the formula. Okay, so let's do a couple of examples. Let's do A cross B. So here to do A cross B, so I'm going to set up my matrix, so I get I, J, K, and then A, so 5, 1, 4, and then B minus 1, 0, 2. Okay, so I'm going to get I times, if I crossed out I's row and column, I would get 2 minus 0. So 2 times 1 minus 4 times 0. And then remember, it goes plus, minus, plus, so now it's minus J times, if you crossed out J's row and column, you would get 10 minus 4. And then plus K times, cross out K's row and column, and you get 0 minus 1. So this gives us, for A cross B, so we've got 2I, so 2 in the I component, minus, this becomes plus 14 inside, but then it's minus, so minus 14 in the J component, and then in the K component we just have 1. So 2 minus 14, 1 is the vector we get when we do A cross B. And again, one important thing to note here is that A cross B is a vector, not a scalar. Okay, so now let's do the second part of this. Let's do B cross A. So for B cross A, again I'm going to set up my IJK, and now I'm going to put B in the second row. So B was minus 1, 0, 2, and I'll put A in the third row, so 5, 1, 4. So now, let's see, when we do this, so we get plus I, and then cross out I's row and column, so that's 0, minus 2, and then it's minus, so minus J, cross out J's row and column, I get minus 4, minus 10, and then plus K, cross out K's row and column, and I get minus 1, minus 0. So in component form for B cross A, I'm getting minus 2, minus 14, minus minus gives us plus, so minus 2, 14, minus 1 for B cross A. So one thing we notice here, and we'll talk more about this, one thing we notice here is that B cross A was just the negative, in this case, of A cross B. So B cross A and A cross B were not the same thing. B cross A was negative A cross B. Okay, so let's do another example. Here I'm going to have us do A cross A. So for A cross A, we're going to, as usual, set up our I, J, K, and then I just have 5, 1, 4, 5, 1, 4. So remember that we have plus, minus, plus, so we're going to get I times, cross out I's row and I's column, and we get 4, minus 4, and then, minus J. So when we cross out, so minus J, cross out J's row and column, we get 20 minus 20, and then plus K times, cross out K's row and column, and you get 5 minus 5. So we get 0 in each component, so A cross A gives us the 0 vector 0, 0, 0. And now I think you should be able to see that when you do B cross B, so there's nothing special about the 5, 1, 4 here, this same thing is going to happen. Do it as an exercise to check, and again you're going to get 0, 0, 0. So if you cross a vector with itself, you get the 0 vector. One thing you'll want to be careful of, this is the 0 vector, not the scalar 0. So when you say A cross A equals 0, you want to be careful to make sure to emphasize that you mean the 0 vector, not the number 0. So either write 0 with the hat over it or write out the components 0, 0, 0. And again, do this B cross B, do this as an exercise for yourself to check and make sure you can do this one. Okay, so let's do another one. So remember now for A cross B, I'm not going to redo it, we already did this one. For A cross B, remember we got 2 minus 14, 1. So now let's do the dot product of A with A cross B. So A was 5, 1, 4, so this means 5, 1, 4, dotted with 2 minus 14, 1. So when we do this, we get 5 times 2 is 10, 1 times minus 14, so minus 14 plus 4, which gives us 0. So A dotted with A cross B is 0, so remember that tells us that A and A cross B are orthogonal or perpendicular vectors. So A cross B is orthogonal to A. Now let's do B dotted with A cross B and see what we get. So when we do B dotted with A cross B, we get minus 1, 0, 2, dotted with 2 minus 14, 1. That was our cross product. So when we work this out, we get minus 2 plus 0 plus 2, which is again 0. So again, we see that B and A cross B are orthogonal vectors. And this is going to be an important property for us that we're going to study in more detail. So what we see here is that A cross B, so the cross product, is orthogonal to both A and B. So this cross product is a vector that's orthogonal to both of our original vectors. And here I've actually plotted the vectors for you. So this blue vector is our A, 5, 1, 4. The purplish vector is our B, minus 1, 0, 2. This red vector is the cross product, and what we see is that the cross product is orthogonal to both of these original vectors.